Swayam Prabha. Digital India. Educated India.
Okay, so far we have seen. So today we will introduce what we mean by public key crypto system. So before that, let us just talk about what are the disadvantage of the system we have seen, the symmetric key or the private key crypto system, and then we will talk about why we need this public key crypto system. And in this talk we will talk about the Diffie-Hellman key exchange protocol. Okay, so let us come back to the so this is the fundamental objective of a cryptography. There are two parties, Alice and Bob. So Alice is choosing a plain text or the message from a source. The source is basically source means the Alice, which is the sender, and Alice is choosing a plain text and Alice is encrypting the plain, sending the plain text. Alice want to communicate to Bob over an insecure channel, and this channel is captured by the attacker. So how securely we can communicate over an insecure channel? So that is the fundamental objective of a crypto system. So far we have discussed what is called symmetric key or the private key crypto system. In the symmetric key, basically Alice and Bob they use a common key. So these two parties, so they use a common key which is basically called secret key shared between Alice and Bob. So this is also called encryption key, and the decryption key is also either same or it can be generated from the encryption key very easily. For the permutation cipher, we have seen the classical cryptography, we have seen if k is a permutation, then the decryption key is the inverse permutation, but if we know the permutation, then we know the inverse permutation. So mostly these two keys are identical or one can be generated from others. So they agreed with a common key k, and then they are communicating use this common key k. So what Alice is doing, Alice is encrypting this M using the key k. This is, we can say, E, and then this is the ciphertext. Alice is generating C and Alice is sending to Bob over the public channel. Now Bob is having this k or the decryption key, which is a function of k or which is basically same as k, and it is easy to get D from E. Either they are same, if they are same, then both is having the common key k. Okay, then Bob is doing the decryption algorithm using this decryption key or the k on this ciphertext. This is basically okay. So this encryption we have seen so far is, maybe it could be block cipher, so block cipher means it could be AES, DES, SPN, RC6, any block cipher we can use. So it is basically a function which is taking a particular bit, say n bit, and key size is say k bit, and it is giving a n bit ciphertext. So it is a basically plain text. Plain text is n bit or plain text or message, and we have a key and we get the same n bit as a ciphertext. This is block cipher encryption. Now decryption is the reverse way which Bob has to do. Bob is giving the input as ciphertext and the same key and revert get the plain text, or they can use with any stream cipher. So they can generate the key stream like K1. So suppose there is a key stream generator or pseudo random key stream generator or pseudo random bit generator which is taking input as a key, secret key, and it is generating the key stream K1, K2, Ki and so on. Okay, so this is the key stream generator, and we choose the this is so from the this key stream generator we get the key stream, and we have the message bit, and we XOR with this we get the ciphertext bit. Okay, so this is the stream cipher. One can use the stream cipher, Alice can use. So same key stream generator has to be used by Bob in order to get back the message in. Okay, so this is the symmetric key setup. So in the symmetric key they are having a common key K, okay. So Alice is having, say, so please go back to the slide. So Alice and Bob, they choose a encryption key E, so which is basically K, and then which is chosen from the key space, and it is they need to share this key. So they need to send this key over a secure channel. So that is also another issue, that is also another disadvantage of a symmetric key encryption, how they can share this secret key. So then what Alice is doing, Alice is having this message M which is coming from the plain text space, and Alice is encrypting this and generating the ciphertext C and sending to Bob over the insecure channel which is controlled by the attacker. Now what Bob will do, Bob will get the decryption key, which is most likely it is same as the encryption key, the same K, otherwise it is easy to get the decryption key from the encryption key, and Bob will apply the decryption algorithm. It could be block cipher or stream cipher decryption and get back the message. Okay. Okay, now let us talk about the disadvantage of this public symmetric key crypto system. So first disadvantage is how they agree with this common key K. So either they have to use a secure channel, which may not be always possible because we are assuming everything is public over telephone. They cannot say this is the key we are going to use. So this is one difficulty, how they can share this secret key. So this can be solved by Diffie-Hellman key exchange protocol. We'll come to know what is that in a minute. So this is one disadvantage. Another disadvantage is, suppose there is a network where n people are communicating. So Alice, Bob, Rob, say Bimal, Polas. So there are many peoples, there are say n peoples, they are communicating with each other, and so suppose they are communicating with each other. So Alice is communicating with Bimal, Bimal is communicating with Polas, Bimal is communicating with Bob, Polas is communicating with Alice, Rob is communicating with Bob, like this. Okay. And suppose they are using a symmetric key setup, they are using a symmetric key encryption. Now for that, so this is a complete graph. So for that, each of these connection we need a key, we need a secret key, and that secret key we cannot use for other connection, because then whatever is communicating with Alice and Bob will be known to Bimal. So whichever is the key we are using here, we cannot use the same key over this for the communicating between Bob and Bimal. So we have to use different set of different keys for all these edges. So that means we need to have how many keys? So n C2 keys. So each edge we need a secret key. So that is the drawback of this, because so then we have to maintain this many keys, symmetric key. So this is one of the drawback of this. So now we will talk about the Diffie-Hellman key exchange protocol, and this was the first work on which direct us to the public key crypto system, and this is the paper by Diffie and Hellman in 1976, and this is the paper by Diffie and Hellman. And this paper name is New Direction in Cryptography. And this paper was published in IEEE Transaction on Information Theory, IEEE IT in 1976. And this, after this work, so this is the starting point of the public key crypto system, and this work is for this key exchange protocol by Alice and Bob. So now we will discuss this Diffie-Hellman key exchange protocol. Key exchange protocol. So this is a way how this two party, Alice and Bob, they are staying in remote place, I mean two different place, how they can agree with a common key K, which we can use for our symmetric key encryption. So to solve this problem, this Diffie-Hellman suggested this key exchange protocol. So this will how these two party which are sitting into different place, say Alice is sitting in America and Bob is sitting in New Delhi. So how they can agree with a common key K. So what they do? So this is the setup phase. So they first agree with a prime number. Let P be a large prime. Why large, we will come to know. So for the time being, just let P be a prime. Okay. Now we consider ZP star, which is basically ZP minus 0, and this is a cyclic group. We know that this is a cyclic group, and this P we make public. So Alice can communicate with Bob over the public channel phone. Okay, we choose this prime P. Okay, so now what Bob will do, what Alice will do now. So Alice will communicate with Bob this P. So this they choose P. So Z, and then they also, so this is a cyclic group. So let G be a generator. They choose a generator. Let G be a generator of this group, of this cyclic group ZP star. Okay. So this G and P, Alice make it public. This can be done by Bob also, but anyway this is the setup phase. So, this Alice make it public, this P and G, this is public. Public means Alice may phone to Bob, okay, so this is our prime number and this is a generator we are going to use, and this they can send over the public channel, which is typically captured by the attacker. Okay, so now they agreed with this P, so ZP star and the generator G. So both the parties is having. So this setup can be done by Bob also. Then in that case, Bob has to send this P and G to the Alice. But anyway, this is the setup phase. So now they both agree with this P and G. Okay, so now what they do? Okay, now so they both have ZP star and the G generator. Okay, now Alice choose a which is between P minus 2, I mean which is less than P minus 1. So Alice choose a. This is a typical secret to the Alice, and this Alice will keep this with herself, and Bob choose a B. Okay, actually not to take 0. Bob choose a B. Okay, now so this is the secret to Alice. This is the and this is secret to Bob. So Bob is choosing this and Alice is choosing this, and then what Alice is doing? Alice is computing G to the power A. So this is a cyclic group. So G to the power A means this is just ZP star. So G times A. So A times G. So Alice will compute G to the power A mod P. So this is, we can denote capital A, G to the power A mod P, and Alice will send this to Bob, this A. Okay. So similarly, Bob is having its secret B, which is chosen by Bob, and now Bob compute G to the power B mod P, and Bob will send this to Alice B. Okay. So Alice is computing G to the power A, Bob is computing G to the power B. Now, so Alice is receiving what? Alice is having A, and this Bob is having B, and Alice is receiving B, which is nothing but G to the power B mod N mod P, and Bob is receiving A, which is nothing but G to the power A mod P. Okay. So now what Alice will do? Alice is having A, which is a typical secret to the Alice, which Alice is chosen, and Alice is receiving B. So Alice will compute G to the B to the power A mod P. Okay, and Bob is getting A, and Bob is having B as a secret. So what Bob will compute? Bob will compute A to the power B mod P. Now this is nothing but G to the power AB mod P, and this is also nothing but G to the power AB mod P. So this is the common key K. So now they have a common key K, which is shared between, which is now between Alice and Bob. So, this is the great idea how they can, how the two parties which are sitting to different place, how they can agree with a common key K, so that they can use the symmetric key encryption for their further communication of the messages. So, now they agreed with this K. Now, if K is 64 bit, they can use, Alice can use DES to encrypt and send it to Bob. So, Bob is having the same key 64 bit. So, Bob will decrypt that message and get the plain text. So, this is the way. So, this idea is just the starting point of public key crypto system, because here we are having some sort of secret key, I mean some sort of this is we are making public and this is we are making secret. So, idea came into the mind that time that okay, so what we can think, we can use something public, something private, and we can make a crypto system. So, that is the public key crypto system. So, that will come back in a minute, and this is the Diffie-Hellman key exchange protocol. And so, the secret is the A or B. So, now to, and these are the public, capital A is public. So, but capital A is G to the power A mod P. Now, this is public parameter, and capital B is also public. So, these are all, whichever we are sending over the channel, these are all public parameter. Now, so this is secret. Now, to get, so if A is known, G is known, G is also public. To know the A, that is called discrete log problem. So, this is called discrete log problem. So, what is discrete log problem? So, discrete log problem means we have given, so P is public. So, given ZP star, G is public, generator is public, and A is known, which is basically G to the power A mod P. Given this, we need to guess A, find A. So, this problem is called discrete log problem, and this is usually hard if P is large. So, what we can do? So, A is, we know A is from, so one way, the brute force method, we can try for all possible A's. So, we know G, so we can try for all possible A's from this set. So, we come A1, we compute whether this is capital A or not, G to the power A2 like this. So, like this. So, this is the brute force method, but the attack time will be the size of the message, size of the P, the prime number. So, that is the reason we have to choose P to be large prime, then it is, this discrete log problem is hard. Okay. So, we will talk about this in more details when we discuss the Elgamal crypto system, which is also based on this hardness of the discrete log problem. So, this problem is usually hard for a large prime discrete log problem. Okay. So, now let us, so just go to the slide please. So, this is the discrete log problem. Instant is giving a large prime P and a generator, so G. So, question is to find A. So, this is the discrete log problem, and this is the key exchange protocol we have discussed. So, there are two parties, Alice and Bob. So, Alice is choosing this A, and Alice is computing G to the power A mod P, and this is GPA. These are all public parameter, whichever is sending over the channel, and then Bob is computing this. Bob is choosing a secret B. So, this B is the typical secret with the Bob, and A is the secret with the Alice. So, they are computing G to the power A, G to the power B, and then they are sending this, and then upon receiving this g to the power, so it is computing g to the power a to the power b, which is basically g to the power ab, and it is computing b to the power a, which is basically g to the power ab. So this is the common key they are sharing. Okay. So this key idea for public key crypto system is coming from here. So this is the starting point of the public key crypto system. So in public key crypto system, so we have two pair of keys. Okay, so there are two parties, say, or more than two parties, Alice and Bob, and say another party is Bimal, or say Bimal, yes, or Palas. Okay, so each of these party, they are having a pair of keys. So this is EB, DB, EA, DA, EP, DP, and this is called public key, or it is also called encryption key, and this is called secret key or private key, and this is also called decryption key. Okay, so similarly, this is the encryption key for Bob, decryption key for Bob. So now suppose Alice wants to send a message to Bob. Suppose Alice wants to send a message to Bob. So that means Bob has to generate this public key private key pair. So this is this setup phase Bob has to run. So this is coming from a what is called setup phase, and this has to run by Bob. After running this, so Bob got Bob's public key private key, and Bob makes this public key public. So it can store into the public key directory or somewhere else, or it can announce this is my public key. So now if Alice has to send a message to Bob, so Alice has to get Bob's public key. So Alice will encrypt this message using the public key encryption, and this is the ciphertext Alice will send to Bob. Okay, now upon receiving this, Bob is having Bob's secret key. So Bob has to decrypt it using the public key decryption algorithm. So using the secret key of Bob, so this is basically E of DB and Y is E of DA of M. So this should give us M. So this is the public key setup. So Alice encrypt the message using the Bob public key and generate the ciphertext, send it to Bob, and Bob is having his own secret key, which is DB, and apply the decryption algorithm, public key decryption algorithm, and get back the message M. Okay. So this should only done by Bob. So that means from EB it should be computationally hard to get DB, because EB is public key is public. So it should be very difficult to get the public key, get the secret key from the public key. So that hardness should be there. Okay, so can you please go to the slide? So choose the encryption key in such a way that computation of the decryption key from the corresponding encryption key is computationally infeasible for the attacker. So that just now we have seen. Then the encryption key can be made public, therefore an encryption key is called public key. Okay. So this public key, suppose everybody is running the setup and they have their public key, and they can post this public key into the public key directory or we will discuss how they can manage the, how we can manage the public key directory at a later stage. So, this is the public key directory. Now, suppose this is the public key crypto system. Suppose Alice wants to send a message to Bob. So, what Alice will do? Alice has to get Bob public key. Either Alice can ask Bob to send his public key, or Alice can get Bob public key from the public key directory, which is again captured by the attacker. This channel is also captured by the attacker. So, Alice got Bob public key. Now, Alice encrypt this message is coming from the message space using the Bob public key and generate the ciphertext and send it to Bob. So, Bob is having his corresponding secret key, which is typically secret to the Bob, which Bob only knows, and which is not which is very difficult to generate from this public key. So, that is the main component of the public. So, then using this secret key, so Bob decrypt this message and get back the M. So, this is the public key crypto system. We will talk about some example next, like knapsack crypto system, RSA crypto system, Elgamal crypto system. Thank you.